Hey guys, welcome to another video lesson. This video lesson is on the circles unit, and specifically we're going to learn about inscribed angles, so angles that are inscribed inside of circles. This is found in section 10.4 of your textbook if you'd like to follow along. Okay, so here we have a diagram, and we have to learn some key terms. So first of all, an inscribed angle is an angle whose vertex is on the circle. So if you look at the diagram, if you look at angle ABC, this red angle, its vertex B is right on the circle. And so that is called an inscribed angle. In meaning inside, scribed meaning to write on or to draw on. So this angle is drawn right inside of this circle. So this angle ABC, it intercepts, right? It catches or intercepts this arc, this blue arc right here, right? It catches that arc, so to speak. So it intercepts, angle ABC intercepts arc AC. And then the other term is to subtend, okay? The angle intercepts the arc, and the arc subtends the angle. Okay, so subtends means that if the endpoints of a chord or an arc, so there's also a chord dropped here from A to C. This chord also this chord also subtends angle ABC. Okay, and likewise, the blue arc, arc AC, also subtends angle ABC. So angle ABC intercepts the arc, and the arc subtends the angle. Okay, so circles are really unique, really special, really amazing shapes, right? There's so much equidistance going on inside of them. And earlier we learned about an angle inside of a circle. We learned about a central angle, and we learned that there's a really cool relationship between the arc, okay, that's created by a central angle, and the measure of the central angle. We learned that those two things are equal, right? The measure of the arc is equal to the measure of its central angle. So now we're going to learn about the measure of an inscribed angle. So if you look at this diagram, we have circle C, and then we have an angle, angle ADB right here. And that angle is an inscribed angle, right? Because we see the vertex D is sitting right on the circle. So we want to look at the relationship between this arc right here, okay, arc AB, and the angle that it subtends, okay? And there's a very special relationship. What do you think that relationship is going to be? It's not congruent, okay, because if we had a central angle, angle ACB, okay, that angle would be congruent to, or that angle's measure would be equal to the measure of this arc. Okay, but if you in your mind's eye, if you just drew this angle ACB, the central angle, you can see that that's a very, very wide angle, right? But when we pull the vertex from C all the way back to D, does that angle get bigger or smaller? Yeah, that angle gets smaller. And how much smaller does it get? Well, this is going to blow your mind. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So this, when you pull that vertex of this central angle, when you pull it back to anywhere on this circle, okay, and in this case we pulled it back to this point, this measure, the measure of angle ADB, is going to be 1/2 the measure of its intercepted arc. So the measure of angle ADB is equal to 1/2 the measure of arc AB. Pretty cool. All right, so let's go ahead and apply that theorem to solve some problems. So here's two problems, A and B. Find the indicated measure. So first let's find the indicated measure on part A. Okay, so let's look at this diagram and let's just sort of pick it apart, parse this diagram piece by piece and see what's going on. So the outermost shape is a circle. Okay, so we have circle P, right? P is the center. Okay, and then we have on top, we have this angle QRT, angle QRT, and we're given that the measure of angle QRT is 50 degrees. Okay. Also notice that PT goes through the center point P. Okay, excuse me, RT. Segment RT goes through the center point P. Okay, so there's one angle, and that angle is an inscribed angle because its vertex is on the circle. Okay, and then now let's go from R to T to S. So we have another inscribed angle down below. We don't know how big this angle is, but we are given that the measure of this arc right here, the measure of arc RS is 48 degrees. Okay, so the first question is, what is the measure of angle T? Well, where is angle T? Angle T is right here. Okay, and so they're talking about angle RTS. Well, this arc RS subtends that angle. Okay, and that angle is an inscribed angle. So we just learned that this angle right here, its measure is going to be 1/2 the measure of this arc. So since this arc measures 48 degrees, this would measure how much? 1/2 of that. Okay, and that is, just substitute in 48 degrees, that is, you can just do the mental math on that. So we know that the measure of angle T is 24 degrees. Okay, let's go on to the more difficult problem, part B. What is the measure of arc QR? Well, where is arc QR? It's over here. Arc QR does not subtend an angle on this picture, in this diagram. Okay, so how are we going to figure that out? What do you think we're going to do there? Well, if you look at arc QR, okay, notice that this right here, RT, that is a chord or a segment, a line segment. It's a chord of the circle that contains the center point P. So what do you think is special about segment RT? What's special about segment RT right here? Well, because it contains the center, it cuts the circle in half. So with your eyes, try to block everything else out of the diagram except for the circle and segment RT. It cuts the circle in half, right? And so it is called a diameter. So when it cuts the circle in half, what do we know about TQR? What do we know about arc TQR? It is, there's a special word for it, it is a semicircle. And we know that the measure of a semicircle is how many degrees? 180 degrees. Okay, so how are we going to figure out how big this arc is now that we know that the entire thing from TQ to R is 180 degrees? How are we going to find this out? Well, if you just know how big this is, we could subtract that from 180, right? And this, the measure of arc TQ, okay, it does subtend this inscribed angle, angle QRT, which measures 50 degrees. So this is going to be twice as big as 50 degrees. Okay, and I think you know where I'm going with this. So the measure of TQ, arc TQ, is going to be 100 degrees. And because arc TQR measures 180 degrees, this part must be 80 degrees. Okay, it must be 80 degrees. All right. So I know this was a complex diagram. The thing is with these complex diagrams to break them down just piece by piece and kind of ignore the part of the diagram that you're not working with and just look at the pieces that you are working with. Okay. All right. So let's get a little bit more complex. Let's add a layer of complexity to this. Okay, and let's discover our new theorem. Okay, so let's start with a circle. So here's this nice, beautiful circle, and I did not name this circle because the diagram is going to get a little bit complex. So we don't need the center of the circle for this next theorem. So we have this nameless circle, and inside it we're going to add angle ADB. And angle ADB, you can see, is an inscribed angle because the vertex D is sitting right on the circle. Okay, and I want you to notice that when we have angle ADB, okay, angle ADB intercepts this arc out here. Now we're going to add angle ACB. And notice that angle ACB also intercepts this same arc AB. What do you think is the special relationship that's created right here? Okay, with angle ADB and angle ACB. What do you think about those two angles? They intercept the exact same arc AB. Well, here we go. If you guessed congruent, you were right. Okay, so in this diagram, we have, this is basically the same diagram. Okay, we have the circle, and then we have angle ADB, and then angle ACB. Those are both inscribed angles of the same circle, and they intercept the same arc. This arc right here, arc AB. Well, what do you think is going to happen with these two angles at D and C, angle ADB and angle ACB? If you guess they're congruent, you are exactly right. So if two inscribed angles of a circle intercept the same arc, then those angles must be congruent. Okay? And it doesn't matter if you moved this vertex at C, if you moved it, slid it all the way down here, or all the way up here, or even up here, as long as it's intercepting the same arc, that angle is going to remain congruent to this other angle. All right, so let's go ahead and use this to do some examples. Okay, given that the measure of angle E is equal to 75 degrees, find the measure of angle F. Okay, so here we have a circle, it's a nameless circle, and then you have this blue angle, angle GEH. Okay, it intercepts this big arc here, arc GH. But you also have this black angle, angle GFH, which intercepts the exact same arc, arc GH. Okay, so since both of these angles, angle E and angle F, intercept the same arc in the same circle, they must be congruent. Okay, there's the arc. Sorry, I got a little sloppy with my digital drawing there. Okay, so they intercept the same arc, so they're congruent angles. So the measure of angle F must equal the measure of angle E. They must both be equal to 75 degrees. Okay, a couple more examples. So let's find the measure of the red angle. So the red angle is this angle right here, angle HGF. Okay, angle HGF. So notice that angle HGF is an inscribed angle, and it intercepts this arc, arc HF, whose measure is 90 degrees. So how big is this? First of all, just think to yourself, does this look like a 90-degree angle? Obviously, no. Does it look bigger than a 90-degree angle? Does it look obtuse? No. It looks smaller. So our answer should be something smaller than 90 degrees. Okay, and if you already learned the theorem, okay, you probably already figured out that is going to be exactly 1/2 of 90 degrees, which is 45 degrees. Here's another example. Okay, so now we have a circle, and we have this black angle, angle ZYW, whose measure is given to us as 70 degrees, and we have this red angle, ZXW. We want to know, find the measure of the red angle. Well, they are both subtended by this same arc, right? Arc ZW. Okay, they both intercept that exact same arc. So what did we learn? Those two angles are going to be congruent. So we know that the measure of angle ZXW is also 70 degrees. All right. I hope that lesson helped you. I hope you understood it. Those two theorems will go a long ways towards helping you solve tonight's homework. Here's a challenge problem. Okay. You do not have to do this. This is optional. But this, not only do you have to apply what we just learned, but we also have, what do we have? We have a triangle DEF inside of this circle. And this is called, when the entire triangle, all three angles, okay, are inscribed angles, this is called an inscribed polygon or an inscribed triangle. Okay. All right. So notice that these two segments, which are also chords, are congruent. So what type of triangle is this? What type of triangle is this? Yes, it's an isosceles triangle. And what do we know about these base angles, angle D and angle F? In an isosceles triangle, base angles are always congruent, right? And triangle sum theorem tells us that all three of these angles are going to add up to 180. Okay, so there's your answer. Hopefully this video helped you. If you have questions, just go ahead and post them as public comments in Google Classroom. You can also email your teachers, and you can also chat or video conference with your teachers, or maybe there's office hours. Look out for that as well. But thank you, and stay safe and stay well.